All right, welcome to PCM and semester two. For those of you that are new to my room, I am Mr. Kosanke. My apologies to you all for not being here today, first day of the semester. I am at the hospital with my wife. She's having a minor medical procedure today that was scheduled months ago. So I will be back tomorrow, but I was her ride to the hospital and then get her home and make sure I'm looking after her and she's okay. So I'll be back tomorrow. Looking forward to seeing you all. Hopefully you had a great extended weekend at the end of the first semester. And with that said, here we go. So we are starting Unit 3 today, Quadratic Functions and Models. These notes should go pretty quick. We'll be here for 2 days. We got 4 pages of notes to go through today. And with that, we'll get started. So just some brief intro here. You can see that we have the graphs already. I have them filled out. These first two, this is half of a quadratic. So in an application process, we don't always deal with negative numbers. So you can see in this one here, we're starting at 0, and we have a quadratic relationship that is increasing. For the second one here, you can see we're starting at the maximum point, and we have a quadratic relationship or curve that is decreasing. Typically, we're used to seeing them like so. So usually we get the whole parabola or horseshoe looking function. So now you can see we have a minimum right here. This one opens up. There's 2 zeros or x-intercepts, if you will. In this case, it was 1, 0 and negative 2, 0. And this one also has 2 zeros, 0, 0 and 4, 0. And you can see the maximum point here. This one happens to open down. They don't always cross the x-axis. We know that sometimes you may have a parabola like this that's down here and doesn't cross the y-axis, or you may have one that opens up and the vertex is above the x-axis. So we know when that happens, we have imaginary roots. That's a discussion for another day. Today is not that day. Okay, definition of our quadratic function. You've seen this before. Ax squared plus bx plus c. That's known as general form. That's one of these bad boys. So we'll focus partially on general form. We'll also focus on vertex form today. So we'll see that and then on a few graphs. So with that said, we will proceed. Okay, here is standard form or vertex form, and this is the one that we will see probably more often in this chapter. So basically, this is a factored version of this where A, that tells us if it opens up or down, and you already know that. So whether it was in this form or the previous form, like this, general form, you know that if this A value is positive, we're opening up. If A is negative, we're opening down. That does not change here in this form. So in standard form or vertex form, A is positive, opens up. A is negative, opens down. H and K is our vertex. Now we've seen H and K before. Previously, you've seen this with the equation of a circle, where H and K represents the center point. For our purposes in this section, in 3.1, HK represents the vertex of our quadratic. So if we look at this very first one here, we see we have a positive A value, which happens to be 1. So we know that it opens up. And our vertex is at 2, 3. So our H value here is 2. Our K value is 3. I want to backtrack just for a second because this is minus H in the formula. So your value of H is the opposite of what you would see in the parentheses. K value, whatever you see here, that's the value of K. H value is going to be the opposite of what's in the parentheses. So here you see minus 2 means our H value is positive 2. So we got a vertex at 2, 3. This is very similar to x squared. So all I did was translate this over. So we know we've got 1 over 1 and then here 2 and 4. So it's the same relationship. On this graph, please note this graph's a little smaller. So I did a scale of 2. So you can see here I went up by 2's on the x and y. So this 0.23 is right here. So 2, 1, 2, 2, 2, 3 in the middle. And I've got 3, 4, 1, 4, 4, 7, and 0, 7. So I just did a scale of 2's. That way we fit a little bit smaller graph here. And then the odd numbers obviously are in the middle. All right, this one here we have a negative a value, -3 this time. And you can do this one of two ways. You can plug the numbers in by hand if you'd like. I just took a couple values from the calculator. So I plugged this into the calculator. I got these values here from our table. Though I know my vertex. I got my vertex from right here. So -5, -1. Again, we got a scale of 2 on this graph. So went over 5, down 1. There is my vertex. And then I got these 2 points from my table. But you could have plugged it in. You could have plugged in -6 into the equation and got -4. You could have done the same thing with -4, plug it in here and have at it. I just went to the table. So at a minimum, we want to have the vertex and a point on either side. Usually I'll try to do 2 points on either side. If we would have went to -7 and -3, we get values that were off this graph. So that's why I didn't continue down here with those points, just because the graph didn't allow us to scale that big, but that's the general idea. So again, the a value, that tells us up or down. In this case, this one's opening down because it's negative. From our standard form here, we can get the vertex of -5, -1. And then I just picked a point on either side of the vertex to get a few more points so I could plot this. Got 2 more examples similar to these. Throw a fraction at you for the a value now instead of a nice clean integer. That's okay. That's not going to change things too much. Still going to do the same way. Use the calculator to help us. So we will start. Actually, I got one more on this page. Let me go down here, show you that first. So here we have 3/7, x plus 1 squared plus 5. So our vertex, I didn't type it in here, but our vertex is going to be -1, 5. So you're going to want to fill that in right there. Vertex of -1, 5. You can see I have it on the graph there. And then I picked 2 points on either side of our vertex. And I'll show you the table there. We'll scroll down. So again, here's our vertex, -1, 5. I picked 2 points to the left, 2 points to the right. Again, how did I get this? I took this equation, went to my calculator, went to y equals, typed this equation in, hit graph, then I went to the table. So second graph will give you the table, and that's where I got these values. Now again, when you're getting decimals here, we're rough fitting them in. I don't expect you to be exact, especially on a graph this small. -1, 5, yeah, we should have that point exact. -2, 5.43, a little bit less than 5.5, so I try to put just a tick underneath. Obviously, you can only make your dots so small, so generally in the middle. And then this is close to 6 3/4 with these two, so you can see I put them closer to 7 than I did to 6. Again, we're not going to split hairs on a couple tenths here, but try to be as accurate as you can. And again, I got my vertex, 2 points on either side, and I can make my graph. Right from the equation, again, we know this opens up because a is positive. A was 3/7, so you're going to fill that in. Vertex of -1, 5. All right, last page of our notes today, so 2 more examples. Again, this time we have an a value that is negative, which means this one is going to open down. So our a value, -2/9, make sure you fill that in. This one opens down, and our vertex here is going to be at 0, -3. We know that because we just have an x squared term here. There's nothing in parentheses to move it left or right. So if I plug 0 in here, I'm going to get -3. That's my vertex. You can see that right here in the table. You could go right next to it, take -1 and -2 for your x values. I skipped a few. Again, I went to my table and I tried to pick clean integers. So if you were to plug this into your calculator and you were to look at -3 and 3 and -6 and 6, you can see you get clean integers here on your graph. So that's why I picked those points. You could use other points if you'd like, but again, I just picked them to get clean integers. So we have our vertex here at 0, -3. Plugged in -3, -5. +3 also gives you -5. And then if I scroll down here a little bit, 6, negative 11, and negative 6, negative 11. So it gives us a pretty good scale of what is going on and what's happening right from this equation. So again, A value tells you whether it opens up or down. Vertex of this one, 0, negative 3. And there's our points on the graph. With that said, we have one more for today. So let's go ahead and scroll down just a bit here. So this one's a little bit different because it's in our standard form here, general form. So we can identify A, B, and C, just like we would with a quadratic formula. And so we see A is 1. It means we're opening up. And I got a B value and C value. And what happens when we're in this form, and we'll learn how to complete the square and do this in the second part of the section tomorrow. For today, we don't need that. The vertex of a parabola in this form is negative b over 2a. So if I take negative 5 over 2 times 1, I get the vertex, or the x-coordinate of the vertex for this parabola, which is negative 2.5. Now that I have the x-coordinate, I can plug it in here into my equation to get the y-coordinate. So if I plug negative 2.5 in here for x, I end up getting negative 0.25. So now I have my vertex. There it is. And I'll just scroll down to the graph here a little bit. So you can see at negative 2.5, our vertex is right there at negative 1/4 or negative 0.25. And again, I just picked a couple points on either side. So again, here's my vertex. So I went 1 to the left, or a half, basically negative 3, negative 2, and then I went out to negative 4 and negative 1. And there is our points here on our table. So now that I have those 5 points, I can go ahead and graph them. So I got my vertex, got a handful of points, 2 points to the right, 2 to the left. I went ahead and added these two. You don't need them. 0, 6 and negative 5, 6. Put them there, great. If not, don't worry about it. But general minimum to the vertex, 2 points on either side, and then you're good to go. So that wraps up our notes for today for the first half of 3.1. So you have the rest of the hour to work on your homework. Again, if you get stuck, look back at these examples. You can rewatch this, hit us pause, whatever, as much as you need to. And we'll see you tomorrow. Thanks.